It's the middle of the World Cup. The Norwegian team has just had a disappointing draw against Switzerland. But that result was completely overshadowed by Captain Hansen's outburst towards Coach Riise after the match. Now the Norwegian public is eagerly awaiting the consequences. What will happen? Will Captain Hansen be sent home? Will Riise resign after a string of disappointing results? What will happen? But then, somewhere out there on the internet, someone is getting ready to push that big red button. And during the next 15 minutes, the front page of NRK.no is being hit by 75 million requests. But before we get into that part, we should probably introduce ourselves.
Yes, first, thank you for having us. My name is Ingrid Guren and I am a tech lead at NRK.no.
And my name is Arne Pedersen. I'm also a tech lead at NRK.no.
And since we are here talking about DDoS attack at NRK and NRK.no, we're going to talk a little bit about NRK first. So we come from the Norwegian Broadcasting Corporation, also known as NRK. And it's quite similar to BBC, but it's a lot smaller and for Norway. And even though we are smaller, we are quite heavily used by the Norwegian population. So we like to call ourselves a gigantic small broadcaster. And in fact, 91% of the population use one of our services each day. And a fun fact, that percentage is higher than the percentage of people drinking water on a daily basis.
That seems incredible to me. People, you should really drink water.
Yeah, you should. And the main purpose of NRK is defining something called the NRK's Statements of Commitments. And the purpose of NRK's overall public media service is to meet democratic, social, and cultural needs in society. And we're also quite proud that we were named Norway's most attractive workplace.
And that's not the first time?
No, that's the third time in a row. These are the products that we deliver to the Norwegian population. We have NRK TV, which is a streaming and on-demand video service. We have NRK Radio, which has multiple radio channels and podcasts. We have Yr, our weather service, which is very heavily used in Norway, but also outside Norway.
Strangely, yeah.
Brazil is one of our main consumers. And we have NRK.no, which is the product that we represent.
Yeah.
So, just so you know what NRK.no is, we are a news page, or we're more than just a news page, because we're going to be the main entry point to all of things at NRK. But we deliver the front page, articles, special formats, recipes, sports, everything, videos, culture. Yeah. And we are Norway's second biggest newspaper. We have about 1.5 million daily users, which is the biggest product at NRK. And quite impressively, 60% of our users visit NRK.no for more than 4 of 7 days a week. So we're quite proud of that.
The loyalty of our users.
And our team, we're about 30 people creating and enhancing NRK.no. And we also have lots of content management systems for journalists, plural there. And we're mostly, half of us are developers.
And speaking of developers, we are here at a developers conference, so it's only prudent to take a look under the hood, as it were. What are we using? What technologies are we using to create NRK.no? So broadly, we can separate our site into 3 categories. We have the front page. That's the most widely used system, and it's built in so rendering layer is mostly TypeScript running on Node, and then we have an in-house developed CMS written in React, and there's some Java there in front of the database and stuff like that. But that's how we build our modern systems. And then we have the article system. That's the oldest part of NRK.no. It's Java-based mostly. Still actually has some JSPs buried there somewhere. So it's that kind of dates it a bit. And then we do a lot of one-off content or systems built for one particular use case, one article, one special feature, or something like that. And in those cases, we are freer to use whatever technologies the developers want to use. So that's where we're trying out new frameworks, trying out new technologies. And everything, well, almost everything that we do runs on Kubernetes. And we've hosted redundantly across 3 data centers. And since we're bare bones Kubernetes, we can actually do that while being across different data center providers as well. So we have 2 data centers from Microsoft Azure, one in Norway, that's obviously our main one, we're serving the population of Norway, and we have one in Western Europe. And then we also have a setup redundant setup in Google Cloud, the Google Cloud Engine in Northern Europe. So these are all running all the critical infrastructure redundantly, and we can switch between them and load balance between them. And the reason that we're so concerned with redundancy and data centers in multiple locations and things like that is our special preparedness responsibility. Now, Ingrid mentioned our corporate mission, our statement of commitments, saying that we're to meet democratic and social and cultural needs in Norway. But in addition to that, we have this statutory requirement to be an accessible information channel for the government during time of war and national crises. So this means, in theory, that we should always be up, we should always be available, even if Norway is cut off from the rest of the internet. NRK.no should still be there serving, informing the public. Now, that's a sort of an in theory exercise. We haven't tried cutting off Norway from the rest of the internet to see if that works, but we're trying to do these preventive measures, trying to think through what will happen and make sure that we think we're covered. Unfortunately, not everyone wants us to fulfill these special preparedness responsibilities. We are living in times of informational warfare, and our role as a non-commercial, unaffiliated broadcaster is more important than ever to provide factual, unbiased news coverage of current events. We all know about the propaganda and lies used in these situations to affect opinion or spread disinformation and hide truths. So it's the job of broadcasters like NRK to correct this by providing the factual, unbiased news to the public. And so they try to stop us. They try to disrupt our ability to provide our content to the users. And there are, of course, many ways to do that. Try to hacking us, for instance, and more physical means. But the by far most widely used these days is DDoS attacks.
Yes. So what is a DDoS attack? Well, we can start with DOS, which stands for Denial of Service attack. And that is an attack that prevents someone or something from accessing something they want to access. In our case, it would mean taking our website down. And the D in DDoS stands for distributed. And this means that the attack comes from multiple places at the same time. And they do this to disguise as normal users. And because if an attack comes from one single IP, it's quite easy to detect this as an attack, because it's very unlikely to have users that check the front page 2 million times in a row. And it's also quite easy to stop the attack, because we can just block the one IP. But if it comes from multiple places at the same time, it's harder to know if this is actual users or an attack. So it's kind of hard to separate popularity from attacks.
So let's return to July 25th last year, when NRK.no was hit by a major DDoS attack, and try to see what happened at that time. And what it looks like from the inside. Our initial alert comes in Slack with our pingdom bot. The Apex test is checking whether or not our front page is responding within a given time limit, responding fast enough, really. And in this case, it wasn't. So NRK.no is detected as down. What we do when we see this alert in Slack is our initial reaction is just open up a browser, navigate to NRK.no, the front page. Is it up? Okay, yes, it is up. Great, then it's not down for everyone at least. So then we log in to ping them, see what is happening. Is this a genuine alert? Is this something amiss with one of the probes in ping them? In this case, it did seem like an actual problem. There were multiple probes failing. But before we were able to delve deeper into that issue, we got another notification saying that NRK.no is back up. Great, everything okay. Well, let's see what actually happened. So these are some graphs from our CDN provider, Akamai. Akamai, as a CDN provider, provides routing and caching and also a set of rules designed to stop this kind of these DDoS attacks before they happen, or rather stop them when they're happening, so preventing them from reaching our service. So the DDoS filter identifies these issues, and they manage to stop a significant number of the requests before they're able to hit our service. Now, as Ingrid mentioned, it's of course challenging to decide what is actually a DDoS attack and what is merely a surge in popularity. And well, we don't know how or what techniques Akamai use to try to detect that. They're not public with this information, obviously, because they don't want evildoers to try to use that information to circumvent those techniques. But if we take a closer look at the requests, so the shaded blue here is the total number of requests, and then the red line is those that have been stopped by the DDoS filter at Akamai. So in this case, it was able to stop around 30% of the incoming requests, and we can see that once Akamai starts denying the attack requests, the attack subsides. It seems like my estimate is that the attackers are seeing that their requests are being denied, and there's no point in just hammering on towards the DDoS filter at Akamai, because that's built to sustain that kind of pressure. So they're just, okay, then attack over for now. And by the way, it seems like the request rate is down to 0 on either side of the attack here. That's obviously not the case. That's our normal usage. So that just is totally overshadowed by the scale of the attack. If we look at the countries where the DDoS attacks originated, this is, since we're talking about distributed denial of service attacks, we can see that they are quite distributed, and these, it should come as no surprise that these are not our main target groups in a normal situation. So you could probably say, well, why don't you just block any IPs not originating in Norway? But you will not say that, because obviously we can't. We want to serve to the Norwegian public and others, obviously, but the Norwegian public, whether they are in Norway or on holiday in Indonesia, or even working at a conference in London. And if you were looking for Norway on that list, you'd actually have to scroll down to the 83rd spot. So even though Norway is now a target for these DDoS attacks, we are currently not a source. Some more graphs. This is from one of our data centers. This is from the Kubernetes rigs. And you can see the request graph as well. You can see that from the pods here in this center right, that when the attack hits, our pods start to crash and the number of pods go down. And that's why because they're unable to handle the incoming traffic, and so the health probe fails, and Kubernetes kills the replicas and will try to, or the containers, and will try to start new ones. And it's able to do that. We're starting up, we're ramping up more than the initial amount of containers, because there is a lot of incoming attacks or incoming requests. But at that point, the attack is more or less over, and it just scales down again. But looking at the timers graphs and things like that, you can. It's obvious that we did actually go down during this time period. And this attack is of a very brief duration, and that's often the case. but that could be an indicator of a larger attack to come. So the attackers might use an initial attack to see where can we actually do some damage, where are the weak spots, and then return with an even more massive attack at the later stage. In this case, that larger attack did not come, so we shouldn't say we're still waiting for it, but so far we're okay. And during these attacks, it can feel like something like this, with like being surrounded by a horde of bloodthirsty zombies. And obviously, in this case, it's too late. You can't really do anything when the zombies have surrounded you like this. That's why we try to avoid it getting to this point. And now we're going to tell you a bit about how.
Yes, because you can't lie awake at night worrying about if your website is going to go down. So we have created 6 steps to help you sleep better at night. And the most important steps are those we can do before the attack occurs, because that's when we have the time, the resources, and are calm and can just implement code changes or better protective measures. So we are going to go through our steps, and they're quite high level, so that you could apply them to your systems as well. And we won't delve into technical details of NRK.no, so we won't teach you how to take NRK.no down.
First one. So I've talked about Akamai. Akamai is a content delivery network. This means that they have nodes all around the globe in close proximity to the actual users. So they're able to handle traffic close to the user, away from our service. And that means that they're able to, using the DDoS filter and other kinds of filters to avoid the traffic hitting our servers. So we talked about the DDoS filter. There's also a web application firewall used to stop lots of requests coming from one single IP, things that are easy to detect, single IPs or requests with obvious malevolent query parameters and things like that. So these filters and these preventive measures are all running on those edge nodes. All of this happens before the requests hit our services.
So to summarize this in one tip, stop the unwanted traffic as far away from the service as possible. So next up we have caching, and we have caching multiple places. So the primary goal is to have caching as early as possible for each application. So in our case, we have initial caching already in the CDN provider, and this is to prevent the request to even hit our applications in the first place. But next up, we have caching within applications and in between applications, so that if one of our services get lots of traffic, it won't send lots of requests to other services, so they also get infected. As an example, the front page of NRK.no has a few seconds caching within the CDN provider. Then it has an in-memory caching in each of the instances running in each of the data centers. And it also caches the responses from the API. So the API, it doesn't really get that many requests at all.
In this way, we are using caching to try to limit how an attack spreads to other parts of our system, infrastructure, other parts of the system, reducing the attack further in. In theory, you can just scale up your services to be able to handle any kind of amount of incoming traffic. But of course, you can't do that, because that will be very costly, and we, as a publicly funded company, we can't waste the taxpayers' money where it's not needed. Instead, we use auto-scaling to be able to automatically scale the resources when traffic increases. But even though the autoscaler can start to scale up the moment it's triggered, it takes some time to get these new replicas and new pods up and running. And so we need to both fine-tune our triggers to make sure that they fire at the first hint of an incoming attack, or incoming increasing in traffic, That means that we might scale up even though it's not needed if that major increase does not come, but it's better to be safe than sorry in those instances. And we also, since it takes time to scale up, we also run at a higher level at default scaling than what is strictly needed to handle the everyday traffic, so that we have some buffer to handle minor traffic increases and also handle the start of a major traffic increase while the autoscalers start getting the new replicas and pods ready.
So you need to buy time by overscaling. Arne has now talked about how important it is to be scaled to handle the traffic. And the next tip is that you need to check that this is actually correct, preferably with a test and not with an actual event. So to do this, we do a load test. It simulates normal or extreme user traffic, and the goal is to find unstable systems or bottlenecks in your system. And doing the actual test is quite easy, as you probably know. You use a load testing service. For instance, we use K6, and you write a load testing script. The hard part here is to know what to actually test, because first, you cannot do it in production because you don't want production to go down, and the goal with this test is to actually take down your system to see how much can you actually handle. So you need a test environment, and the test environment has to be as similar to production as possible, but you probably cannot create your whole production environment. So you need to mock out some integrations, but not all, because you don't want to test. You need to test everything. You need to see if this application actually works as intended. For instance, we usually mock out third-party integrations, for instance, Firebase, because Firebase blocks you if you send too many requests. And to do this, you actually have to know how your system works. And after you have tested one part of your architecture, you will probably do a test on some other part that has been mocked out in the first test.
It's never the parts that you think are going to fail, or the parts you think are the bottlenecks, that are the actual bottlenecks when things happen. So you need to know everything about your system, about your integrations, both to find the bottlenecks, but also to be able to make sure you are testing it correctly and handling and scaling up the things that are needed to scale up. But you can't really scale up everything, and not everything is as important at any given time. Tomorrow, it's Saturday, I think. Tomorrow is the grand finale of the Norwegian Melody Grand Prix, the Norwegian leg of the Eurovision Song Contest. So families all around Norway will gather around the TV, mobiles in hand, ready to vote for their favorite, the one who's going to represent Norway in the Eurovision Song Contest later this spring. And during that short voting window, it's obviously critical that our voting system, our login, the voting page, all that stays up. But we don't really need to cater to that random guy that just happens upon NRK.no and tries to search who was the Prime Minister of Norway. Do we have anything about the Prime Minister of Norway in the 80s? So we can actually scale down our search service and then scale up our voting rigs, our loading, our login stuff, and things like that. And these priorities will change during the week, during the year. So when it's a breaking news situation, we need to prioritize the front page and the articles. And during election night, which is the biggest night for NRK, we actually have scaled down or even turn off the login and personalization to be able to cache our content better, to serve the same cache content to everyone, because we know that there's going to be a huge traffic surge that night, and we don't need to worry about everything else. That can be handled in the morning.
And this always sounds so hard, but you actually need to accept that not everything can be up all the time. And then you should ask yourself, what is the absolutely most important thing that we do or deliver? And that one thing is your purpose, and everything else is a bonus. I mean, important bonus, but still. Our main purpose is to deliver information to the Norwegian people, as said, and that means that we can do some priorities. we can turn off feature testing, as Arne mentioned, during critical periods. We do not do any feature testing during election time. And we also have a data center in Norway, which gives us geographical proximity to our main users, which is Norway. And it also means that we can prioritize this data center if something happens. That means that that's the last data center that we will take down because that's closest to our main users.
Any service that you build is going to have a main purpose. It's going to have other parts of the service that you really like, but that aren't as important. And in critical times, you need to remember what is the main purpose of your service. In our case, it's pretty simple because we have it clearly defined in our statement of commitments and also the special preparedness responsibility. But any service has one purpose, at least.
So I'm just going to summarize a bit. This is the technical protections we have talked about added to this simple illustration. So when we have a user accessing our web page, they will hit the CDN where we have DDoS protection, web application firewall, and caching. And if the data is not in the cache, it will reach one of many multiple instances of the application where we have caching. And we also have autoscaling to be sure that we have enough instances running all the time. And if it's not there, it will ask the API.
This is another example of the DDoS traffic attack. Or is it? No, these are the votes received during last Saturday's semi-final in the Melody Grand Prix. But as you can see, the traffic pattern here is very similar to what we saw from the earlier DDoS attacks. A very peak-based burst of traffic. So this is not a DDoS attack, it's what we like to call a benevolent attack. It's a surge in popularity. Now, of course, we know about these popular shows, the Melody Grand Prix, in advance. So we're able to take precautions and we know that they're going to vote. We know that we're going to see these kinds of peaks. But we don't always know about these events in advance. We are a news site, and the news happens when they do. We can't control what happens in Norway or around the globe, and news will be reported when it happens. And everyone with the NRK app installed on their phones and push notifications enabled will get a notification when things happen immediately. Everyone will get it at more or less the same time. And if it's something that looks interesting or scary or fun, they will click that notification, open up our article or our front page, and read all about it. And then we get these sudden surges in traffic that we can't really prepare for or we don't know about in advance.
Yes. To illustrate this, we are going to give you a concrete example from 2022, more precisely the 8th of September. When Queen Elizabeth II passed away. And even though she was not the Queen of Norway, the news were read quite heavily. And they got lots of attention and was read by many people. So we found this graph from this day, and this is open push notification during the day. You can see the first spikes, they are not related to the Queen. But around 2, you can see the first news about her being ill. And then the high peak at 7:50 is the news that she had passed. And as you can see from this graph, such event gives us some burst of traffic. And we didn't know about the news in advance, and we couldn't prepare for it other than just
in general.
In general.
So sending these kind of breaking news push notifications is somewhat like opening the doors on Black Friday, a sudden rush of people trying to get in. And the preventive measures we've been discussing helps handle these traffic peaks as well. But with one crucial, obvious difference. We don't want to stop these requests. We don't want to deny these users from reading our front page or reading our content. So So luckily, since these traffic peaks do not reach the same dimensions as the DDoS attacks do, we usually handle it okay. Usually, but not always. And so we're going to give you a few examples of when we didn't. I guess to try to tell you that it's okay to fail once in a while. I don't know why. So the first one is from last summer, I think. Yeah. So there's in Norway, NRK has regional offices all around Norway, and they have their own journalists do their own reporting, use any tools made available to them in the CMS, perhaps without reading the fine print. So in this case, the office in northern Norway wanted the public to vote for Nordland, the region's most beautiful mountain tour. And oh boy, they did. There was probably some scripting involved as well, someone wanting their favorite mountain to reach the top, as it were, on that list. And they were using the informal poll plugin that we provided, and that was not built to handle these kind of things. So it crashed. And we didn't actually know about it until they called us and say, hey guys, our poll is down, what's up? And then we could see that, okay, that's not, you not know. And long story short, we actually restarted that poll using the same voting backend that we use for Melodi Grand Prix, the biggest voting event outside of the election in Norway. So they really like their mountains there up in the north.
I'm going to walk you through one of my personal favorites. So first, cross-country skiing is quite big in Norway. It's probably because we are best, or because no other country care about the sport. So this was during the Winter Olympics a few years ago, and we started getting messages about NRK.no being down and that we had technical problems. And we did as we always do, we checked, and it worked on our machines. So it was probably not a thing. Well, we got more messages and we said, okay, and we checked the logs, we couldn't find anything. So we started checking more. And we found that in our CDN provider that a lot of Norwegian IPs had been blocked. So what had happened? Why were these people being marked as attacks? Well, the Olympics happened during daytime, or more precisely work time. So these were employees working at a company, and they were having the same IP because they were sitting on the same internet connection. And our CDN provider thought they were attacks, so they were just blocked. So we did two things to fix this. First, we have event mode that we turned on. It says that the event or the user pattern is different now than normally. So it's kinder before it blocks users. And also we have allowed list some of the company IPs because these were big companies in Norway, because it's easier to allow list them than to tell them not to watch the Winter Olympics during work.
So this is an older example, but in some years ago, NRK aired, yeah, it's a strange picture. NRK aired a reality dating show called literally When the Chemistry is Right. And they were trying to match participants using science. Smell, for instance. And it was a strange show, but it became quite popular, and with a lot of people following from week to week. And in the finale, the winning couple was revealed, ready to start dating proper. And during the credits, a voiceover said something like, and if you'd like to learn more about how that dating went, visit NRK.no now. And oh boy, people did. So this is something that we could have been made aware of in advance, but and prepared for. But we, on the sort of web side of things, we didn't know that we were going to run this promotion at the end of the finale, and the people from the TV production probably didn't think it could be an issue being used to broadcasting. So we got a good load test out of it, and we did actually go down or crash at that point because, well, this was before we were able to implement all the tips we've talked about today, and all our traffic was running through the same load balancer, and that meant that all images and assets and scripts and stuff, including all the HTML files or the web content, and it became too much of a bottleneck for that old load balancer, and it also ran a lot of rules and stuff like that. So, and just to mention that things takes time to fix. The next year, they actually got a new season of this show, and during the finale, the exact same thing happened. So, did we learn something? Yes. Did we manage to fix it in time? No.
Okay, so this is not a failure, but we're going to mention election again because it's quite big in Norway and one of the main events at NRK and happens every second year. So at 9 p.m. the polling stations close and the results of the early votes are released along with the first projections. And we are not allowed to give out the first projections or results before 9 p.m. If we do, the election could be annulled. And if we don't deliver at 9 o'clock, we're not adhering to the NRK statement of commitments and we get fines.
We're not informing the public.
Just at 9 o'clock, we have to deliver the results. And people know that the results come at 9, so they sit and wait and refresh the webpage to see what are the first results. So here you can see our graphs from 2021. And can you guess what time it's 9?
So we mentioned the Melody Grand Prix. That's obviously not the only public interaction event we have throughout the year. We have a lot of other award shows and competitions and even our own version of The Masked Singer. And many of these have these short voting windows where the host says something like, "Vote for your favorite now." And everyone does that, and in the next 5 minutes, while that voting window is open, we get a lot of requests. So this is something we can and do prepare for, and we have a lot of practice preparing for these sort of events, because it's a live show. We need this to go correctly without a hitch. And talking about Melody Grand Prix, NRK has been running it since the early 60s. A few years ago, I think probably around 2020, we started doing online voting by the public during these events. Before that, it was SMS-based, and before that, it was all juries selecting. But 2020 was the first year we went all in on online voting. And we even had emojis where you're able to react on the artist's performance by clicking in the appropriate emoji, and you can, not just once, as many times as you wanted, and those emojis from the public would then confetti out during the artist's performance. And I'd like to show a short clip from that night. This is from Grand Prix.
Og så det jo sånn da, at I tider der, på et tidspunkt her nå, så har altså da dere I det norske folk bikket en 50 millioner emojis der ute, så vi har hatt litt grann trøbbel med det nettsystemet der på NRK.no, men håper at alt skal være på stell etter hvert. Og så skal vi altså da foreta en nydelig avstemning, og forhåpentligvis da, eller garantert, kåre en nydelig vinner av Melodi Grand Prix 2020. Og så håper vi på sikt at vi skal få den avstemmingen I gang. Det jo lov til å drømme om at det skal skje.
One can only dream. It is. We did get the voting underway, and we were able to select a lovely winner, as Ronny said. Unfortunately, she was not able to perform at the Eurovision Song Contest due to a small worldwide pandemic, you might remember.
Yes, so I'm going to bring this back. This was the layers of protection that we talked about earlier. Now it's dark blue. So, how would you access the API if you were a developer? Well, it's quite the same. You have an address, it will go through the CDN, it will go through one of the applications, and you will get the data from the API. Of course you won't. You will just ask the API directly. And is there a problem with this? Well, yes. because all the protection we have added is now gone. And this leads up to the final type of attacks that we are going to talk about.
Yes, attacks from within. We call this category. Why wait for the public or the evildoers to take us down when we can just do it ourselves? So we call this attacks from within, but we might as well call it accidents or shortcuts or poor planning or even we should really know better. So this is when we're generating the excessive amounts of traffic ourselves just due to improper configuration or just testing something or not considering the implications of our implementations. And these attacks are extra scary because, as Ingrid shows it, they circumvent all the measures we've put in place to protect our services. And not only that, they can use these services in ways they weren't originally designed for. In a company like NRK, we have different teams building different components, different APIs. And you might make usage assumptions about that other API that team was did not plan for.
So we are going to give you some examples of our failures, because we have some of those as well.
Failures again?
Oh, yeah. So the first one, I'm just going to talk in general terms, because we've done this so many times. So let's say you have a system with lots of data, and you suddenly need to make changes to the data. And it's too much data to do it manually. But luckily you have an API, and you can just write a little script and post the data to the API, and boom, all the data is updated. Of course it's not, because you forgot that your API is actually quite slow, and it's placed behind a queue because it's so slow. And what happened when you send a few thousand requests at it? It goes down. So much for all the protection you have added and the queue and all the good thoughts of your architecture. A
few years ago, we added videos to the front page of NRK.no. And then the product team or the journalists said, well, we've seen that other sites have auto-playing videos. Can't we have that? And our initial response was obviously, please no, because no one likes auto-playing videos. But they were quite persuasive, so well, we'll try. And then so we enabled the auto-playing videos. Only thing was that we had not talked to the team running the on-demand streaming side of things. So any loading of or starting and playing a video would send a request to that API, say these are the parts of the file you need to load, stuff like that, the manifest and so on. And so that was not scaled at all to handle the traffic from the most used page on NRK. So that went down, the streaming service went down, NRK TV, and there was some shouting, and then we got turn off the auto-playing videos. We discussed it with the other team, got the proper routes set up, and we were able to, unfortunately, enable it again.
Yes, and one final friendly attack, because we have previously talked about load test and that it's hard to do load tests on new systems. So, of course, we have an example from that too. We've talked about the election too many times. So this was the day before the election, and we were doing the load test on our application. And we had created a good test environment. It was a pre-production environment, very similar to the production environment, actually too similar to the production environment, because we had an integration to our production environment. So when we started doing the test in the pre-production, we got alarms in the production on applications that were not at all related to our test. And first we thought, well, that's just a coincidence. So we did the test again, and no, it was not a coincidence. But it was surprising. And what we found out was that we had used our production Firebase account. I said, mock out your Firebase integrations. So that when we did the load test, Firebase blocked us, which means that the other applications using Firebase also got blocked and got down. And they were production applications. They were not critical. It wasn't a big problem, but it was stressful. Yeah. And it was the day before the election, and it was not how we we're going to do the load test.
That's not when you want extra stress or pressure. So we should really add one extra tip to the list to try to avoid internal attacks, because there's no point in setting up all preventive measures if you're just going to, from the external attacks, if you're going to let the internal ones take you down. So consider how you and your fellow developers are accessing the services, both during development and with internal traffic, and make sure that all the integrations have circuit breakers and other systems in place to avoid overloading. If a service has a cache, use it, obviously. Really, just pretend that any service or microservice or app within your system could be evil, and put all the preventive measures in place.
So, do not bypass your own protection.
And here we are. The 7 tips on how to avoid having your planet blown up, as well. In recent years, DDoS attacks have become more frequent. It's something we've learned to live with, and these are based on our experience on how to actually live with that situation. But as you've seen, but even if you're not a target of DDoS attacks, actually, you might have traffic from your actual normal users, or even a tired developer running an incorrect script. But handling these attacks, that is hard, and like us, you will probably fail from time to time. But hopefully we've shown you that it's okay to fail. If nothing else, you get a kind of good story out of it. And that's about it, I think.
I think so.
Any questions? Oh, you can clap. Don't stop. We have a question in the back.
Sure. One thing I found with WAFs is it turns into a game of whack-a-mole.
Yeah.
Or user policies protection because the users keep getting blocked. Is this something you experienced, and how did you deal with it?
Okay, so the web application firewall and the rules that we set up, they might prevent actual users to accessing the service, and how do we deal with that situation? I think it was a question, and well, it is the game of whack-a-mole. We keep tuning those triggers or those limits to try to figure out what is the correct way of where are they. What is the correct limit or threshold? What we've done recently is try to use different, because these rules are set up by domain, so we try to separate our main content domain, www.nrk.no, from API requests and things like that, and also images, so that if you're blocked from some API requests, you will still be able to access the content. And we try to, and we have that in mind when building the services. And if something is incorrect, or we have a page with too many elements using dynamic elements, which might happen since we have the journalists using whatever they want, then you only lose a bit of interaction, a bit of the dynamics of it. You will still be able to read the content, which is the important part for us. But it is difficult. Another question?
In Cloudflare, they publish all their IP addresses, so you can just say to the hosting service, only accept requests from these IP addresses. That forces all the traffic to go through Cloudflare and the WAF.
Yeah.
Is there not an equivalent in Akamai?
Yes. So we have that for. We don't have that for our internal services because we want to be able to test things from within, and we also have things that are not available from through Akamai. So that's why we route things internally as well. But any traffic for our major apps, that's always handled, or the outer layer is always handled limited through the IPs from Akamai. But the internal APIs are not. They are just internal requests. Another question from Mac?
Did any of your services explicitly implement rate limits? I noticed you said overscaling ad strategy for dealing with load, but what about the opposite of if we get too many requests per second on something, start rejecting them because we're overloaded?
We have that actually. That's something we try to do where if we reach a sort of limit, we can start denying requests with saying too many requests. We have that on the search service. We try to do that on the unimportant parts of the service. That comes back to the tip about prioritizing parts of your service so that we're able to, or we want everyone to be able to access the main content, but other parts we can say, okay, this is getting too much traffic now, so we'll just dial it back a bit.
We also have set criticality for all of our apps, and it changes during the week or during the year, depending on what's important right now.
Yeah.
So every app has a criticality number, so that if, for instance, our cluster will be full of pods, it will start taking down unimportant apps, because we say that not everything is as important, even though it's hard to say that, but
that's something that's handled by Kubernetes. You can say that this deployment is more important than this one. So if it needs more room to scale, just shut down replicas of the other one.
So we don't. Search is not important at NRK.no. It also sucks.
Yeah. If there are no further questions, thank you for the time. Thank you for NDC for having us, and enjoy the rest of the conference.